This video will introduce you to common functional groups in organic chemistry. And the type of problem that we'll tackle at the end of the video sequence is the identification and naming of functional groups within an organic structure. A functional group is an atom or a group of atoms with characteristic chemical and physical properties. In general, the reactivity of organic molecules that we'll see later in the semester arises from those functional groups and their behavior. We'll start by taking a look at a few common examples, and you can try to see if you can draw these on your own as we name them. An amine is a nitrogen with 3 other groups bound to it, and those groups can be alkyl groups, like the 2 ethyl fragments here, or they can be hydrogens. An alcohol is an oxygen bound by both an alkyl group and a hydrogen. A thiol is very similar and is a sulfur bound by an alkyl group and a hydrogen. And finally here, an alkyne is a carbon-carbon triple bond, and it can have either an alkyl group or hydrogens bound to each carbon. And these are just a few common examples, but you can find a full list of functional groups that you should be comfortable with in your text. To help us think about functional groups, we can organize them into different classes. In the first class, we have a carbon singly bonded to an electronegative atom, our functional group, abbreviated here as Fg. And here, remember that our notation of R indicates an organic fragment or an alkyl group. And again, we're just going to walk through a few examples of functional groups that fit into this class. And as I draw these on the screen, I'll encourage you to draw them in your notes to practice and to get comfortable with how to draw different functional groups. And as you draw each one, I'll also encourage you to try to identify or name the functional group. And then once we've drawn them all, we'll go through and we'll name each one together. Next, we'll go through and name these common functional groups. So feel free to pause the video and take a crack at naming or identifying them yourself before we go through them together. An alkyl halide is exactly what it sounds like. It's an alkyl group bound to a halogen. An alcohol we just saw on the last slide, so you should be able to identify it. It's an oxygen bonded to an organic group and a hydrogen. An ether is an oxygen bonded to 2 different organic groups. The thiol we also saw on the last slide is a sulfur bonded to an organic group and a hydrogen. An amine, also a repeat here. Hopefully you were able to identify that one as well. This is a nitrogen bound to 3 groups, either organic groups or hydrogens. And in this case, those are 2 alkyl groups and a hydrogen. A thioether, this is a new one. This is just like an ether, but has a sulfur in place of the oxygen. So a thiol is like an alcohol, but with a sulfur in place of the oxygen. A thioether is like an ether, but with a sulfur in place of the oxygen. And finally, the last one here is a phosphate, which has a phosphorus as the central atom, which is then doubly bonded to an oxygen and singly bonded to 3 other oxygen atoms. One that's an alkoxy group, and 2 that are anionic or negatively charged oxygens. So for our functional groups here, the phosphate is pretty unique because it's our only charged functional group on this slide. The others are all neutral. So remember, each of the functional groups in this class bears an organic fragment that is bound to the electronegative atom, the oxygen, nitrogen, sulfur, phosphorus, through a single bond. The second class of functional groups that we'll explore today are carbonyl-containing compounds. And a carbonyl is a functional group on its own, and a carbonyl is a carbon doubly bonded to an oxygen. When a carbonyl is bound to 1 organic group and 1 hydrogen, then we classify the whole functional group, including that hydrogen, as an aldehyde. When both groups bound to the carbonyl are organic groups, then we have a ketone. When the carbonyl is directly bound to a nitrogen, then the whole functional group, including that nitrogen, is an amide. Okay, similarly, if the carbonyl is directly bound to a sulfur, then the whole functional group is a thioester. A carbonyl directly bound to a chlorine is an acid chloride. And this extends to other halogens as well. We can have other types of acid halides, but the acid chloride is by far the most common. And finally, a carbonyl directly bound to an alkoxy group, or an OR, is an ester. The third and final class of functional groups that we'll look at today is a classification of my own, not one that you'll find in your textbook. And that is functional groups that contain pi bonds, carbon-carbon double or triple bonds. You will encounter these endlessly throughout the semester, so it's important that we know their names and we can use them in conversation. First, an alkane does not fall into the category, but it's an organic compound with only sigma bonds, only single bonds, and no functional groups. An organic compound containing a carbon-carbon double bond is an alkene. An organic compound containing a carbon-carbon triple bond is an alkyne. And an organic compound containing a benzene ring, or a ring structure with alternating double and single bonds, is called an arene. Before we wrap up this video, let's do a quick concept check. Go ahead and pause the video and take a minute to identify all of the functional groups in the molecule shown below. Okay, welcome back. We'll take a look together. I'll start at the left side of the molecule, and I'll identify and name each functional group as I move across the structure. The first one we encounter is an amine, and characterized by the three groups bound to a nitrogen. Then we encounter an alcohol. It's the oxygen bound to both an organic fragment and a hydrogen. Moving further, we see an ether. Remember, that's an oxygen bound to two organic fragments. And in this case, one of those fragments is an arene. And finally, at the end of the structure, we have an amide, a carbonyl that's directly bound to a nitrogen. And remember that this is a single functional group, an amide. It is not a ketone plus an amine. The groups together constitute one functional group that we call an amide. We'll end our discussion of functional groups with this question that we posed at the beginning. So go ahead and pause your video and circle and name any functional groups in the structure shown below. Okay, this question is more straightforward than the one we just tackled. There are only two functional groups to identify here. The first is an alcohol, again characterized by the oxygen that's bound to an organic group and a hydrogen. So while we're here, let's take a minute and further classify this alcohol. We can be more descriptive and indicate not just that we have an alcohol, but that we have an alcohol that's on a carbon with three carbons or organic groups bound to it. And so we can denote this alcohol as a tertiary alcohol. Tertiary indicating the three carbons bound to the carbon that bears the oxygen. So an alcohol and a carbon bound to two other carbons would be a secondary alcohol, and an alcohol and a carbon bound to one other carbon would be a primary alcohol. The second functional group we have here is an amine, and we'll do the same thing here and be a little bit more specific about what kind of amine we have. And to do that for an amine, we look instead at how many hydrogens or organic groups are bound directly to that nitrogen. So a nitrogen bearing only one organic group and two hydrogens is a primary amine. A nitrogen bearing two organic groups is a secondary amine, and a nitrogen bearing three organic groups is a tertiary amine. Okay, so in this structure, we have a primary amine and a tertiary alcohol.